Perform the indicated operation. Simplify the answer when possible. Well, to add and subtract with radicals, the radicand, the number underneath the radical, must be the same. It's not in this case, but we can simplify the radicals. What we have to do is find the largest perfect square factor in each radical and remove it. So I'm going to list some perfect square factors. So 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64. 9 squared equals 81. And 10 squared equals 100. So these are perfect squares. So the largest of these perfect squares that will divide into 12 without a remainder would be 4. 4 goes into 12 3 times. I'm going to break this down to the radical 4 times the radical 3 into separate radical factors. Well, the square root of 4 is 2. Since 2 times 2 is 4. Radical 3. So that first term simplifies to 12 radical 3. Now the second term. The largest of these perfect squares that will divide into 75 without a remainder would be 25. 25 goes into 75 3 times evenly. So if I have the square root of several factors, I can break it down into separate square roots. So it's the square root of 25 times the square root of 3. So I'll bring the 3 down. Now the square root of 25 is 5, since 5 times 5 is 25, and I'll bring down this radical 3. So now I have 15 square root of 3 minus 6. Now for 48, 4 does go evenly into 48, but it's not the largest perfect square that goes into 48. The largest one would be 16. 16 goes into 48 3 times. I'll bring the 6 down, and I'll break that radical up into separate radical factors. So the square root of 16 is 4. I'll bring down the square root of 3. So I have minus 24, the square root of 3. So I'll keep my square root of 3, since the radicand is the same in each case. And I'll add and subtract the number factors. So 12 plus 15 minus 24. So 12 plus 15, that's 27. Minus 24, that's 3, square root of 3.